when there's no tax and when there's a tax that chokes off the whole market, then the global incidence, which is just the ratio of the consumer to producer surplus, is the same as the incidence formula, except where the pass-through rate, the local pass-through rate, was replaced by this average pass-through rate. And so what does that tell us? Well, you know, when we say the consumer bears the tax, right? That sounds like, oh, poor consumer, right? They're so vulnerable, they just have to pay the tax, right? But really, the right way to think about it is that the consumer is the one who's benefiting from the market existing in the first place. They're getting all the surplus. So of course they're going to bear the burden of the tax. If you tax a good where the consumers are getting all the surplus, that's going to hurt the consumers. If you tax a good where producers are getting all the surplus, that's going to hurt the producers, right? So the person who pays the tax is the person who's getting surplus from the market existing in the first place, right? I mean, that's not quite true because, of course, there's a difference between the local tax and the global and whatever. But to, you know, your basic intuition is whoever, the person who pays the tax is the person who benefits from the market existing. And in fact, there's a very nice study that's being done by a guy who will give a presentation here in several weeks, which is looking at who gets the benefits from globalization. And the way they're looking at that is they're looking at when there are changes in international prices, is that mostly getting passed on to consumers, or is that mostly being captured by producers? Looking at the pass-through rate. And then based on that, they can determine whether globalization is mostly benefiting the producers in a country or the consumers in the country by basically integrating that up. OK, so monopoly incidence is fundamentally different from competitive incidence in a few ways, but similar in other ways. So it's still the case that who physically pays the tax is irrelevant to whether the prices are going to, is irrelevant to the economic incidence of who ends up paying the tax. So again, we can call the pass-through rate the effect that a tax on the producer has on the prices paid by the consumers. So now getting back to King Solomon's question, the reason why a subsidy is always going to lead to lower prices is that a subsidy on the consumers is the same as putting a subsidy on the firm. And if you subsidize a firm, they're obviously going to produce more, right? And if they produce more, they're going to have to charge a lower price, right? And so a subsidy on the consumers will always lead the eventual price that the consumers get to go down, right? OK. Second, remember that before, when we put a subsidy on, or a tax, that just got in some way split between the two firms, between the firms and the consumers, right? But now it gets more than split. Because if we put a tax on, that's actually going to reduce the quantity. And the quantity was already below what it should have been, right? And so that's going to cause some excess burden, some additional dead weight loss, not just be split between the two sides. So in particular, the firm is going to choose its quantity so as to maximize its profits. So does anyone want to use that to tell me by the envelope theorem how much the firm is going to be hurt when it has to increase the tax, when the tax increases? Envelope theorem says the firm chooses quantity optimally so we can hold fixed the quantity when we consider the impact of the tax on the firm's welfare. So can you use that to derive what the effect of the tax on the firm's welfare is here? Anyone? Well, we can just hold quantity fixed, right? And take the derivative with respect to tax, holding everything else fixed. And so that just gives the effect, the quantity. So what that says is that the firm bears the full burden of the tax. For every unit of taxes increase, the firm has to pay all of the revenue that the government gets out of that. But in addition, the consumer is still paying the pass-through rate times the quantity. right? And so there's a dead weight burden. There's an excess burden in addition to whatever the government gets, which is proportional to it's equal to the pass-through rate, right? For every unit that the government raises, the firm fully pays that, and then again, the consumer pays the pass-through rate times that, right? And so what that tells us is for every unit of tax, the firm pays 1, and the consumer pays the pass-through rate. And so the incidence now is equal to the pass-through rate rather than the pass-through rate over 1 minus the pass-through rate. Right? And we can just integrate this up before. And so the ratio of consumer to producer surplus is now the pass-through rate rather than the pass-through rate over 1 minus the pass-through rate. So obviously, that means that the ratio of consumer to producer surplus has fallen, right? Because before you had pass-through over 1 minus pass-through, now you just have pass-through. And so therefore, of course, the producers are capturing more of the benefits of the market under monopoly than under competition, which makes perfect sense, right? OK, so to see this graphically, remember that the profits that the firm makes are the area between the marginal revenue and the marginal cost curve, right? Now, if I increase the tax, how much does that reduce profits? Well, it's basically this strip which has a height which is equal to the change in the tax, and which has a width which is equal to the quantity that was being produced. Now, in addition, there's this little triangle here. But for a small change in the tax, that triangle is very small, right? And so that's the envelope theorem, right? It says that it's exactly this quantity times the change in the tax. OK. Now, under monopoly, therefore, logic of incidence is changed in 2 ways. So the first was that the dead weight loss means that incidence is not just split between the 2 sides. There's this excess burden, and that changes how much is borne by the consumers and by the firms. A second thing is that the pass-through rate is now going to depend on the marginal revenue curve, not the demand curve. Because remember, the way we derived the pass-through rate before was that demand and supply were equal to each other. But that's not true anymore. Now the equilibrium is going to not be price equals marginal cost or demand equals supply. It's going to be marginal revenue equals marginal cost, right? So let's consider the pass-through rate. So marginal revenue equals marginal cost plus the tax, right? So let's again use the implicit function theorem. We now get the derivative of the marginal revenue times how much the quantity changes when the tax changes is equal to the derivative of marginal cost times how much the quantity changes when the tax changes, plus 1 for the direct effect of the tax. OK, so dividing through that gives us the change in quantity from a change in tax is 1 over the derivative of marginal revenue minus the derivative of marginal cost. To figure out how much that changes prices, we multiply by how much price changes when quantity changes, right? And so that gives us the derivative of price over the derivative of marginal revenue minus the derivative of marginal cost. Now remember that marginal revenue is equal to price plus price prime times quantity. I want to now define the marginal surplus, that was that term I was talking about before, right, as the negative of this term. It's how much additional surplus the consumers get when the quantity increases. And as we usually do, I want to identify the marginal cost curve with the supply curve, right? The supply curve is just the inverse of the marginal cost curve, right? So MC prime is equal to P over Q times the elasticity of supply, just as P prime is equal to negative of price over quantity times the elasticity of demand. That's what we did earlier, right? And so this gives us that the pass-through rate is equal to this. Canceling some of that stuff out, we get that the pass-through rate is now 1 over 1 plus the elasticity of demand minus 1 over the elasticity of supply plus 1 over the elasticity of the marginal surplus curve. What's the marginal surplus curve? Again, it's that area between demand and marginal revenue. OK, so notice that if we drop out this term, things look pretty much as before, right? It's basically 1 over 1 plus the ratio of elasticity of demand to supply. There's this negative 1 here, but that really doesn't affect any of the basic features of what's going on. But this additional term is something new, right? This is the slope of the marginal surplus curve. Now, notice that we had before that marginal revenue curve actually increased. And that led it to be the case that when you increased your marginal cost by a little bit, suddenly you had this jump in the price, right? That was what we got out of ironing, right? Now, that came from the fact that the marginal surplus had to be really quickly shrinking in that region, right? And that's what made this go infinite, right? Because this thing was really negative, and that made this whole thing negative. So that's the basic idea that we're going to follow now. That came from the fact that we said demand was so convex. The more convex demand is, the more negative this is, and the higher pass-through is going to be. In fact, eventually maybe infinite. When demand is concave, this is going to be negative. Sorry, this is going to be positive. And that's going to decrease the pass-through rate. And that came out of those pictures that we were looking at before about, when demand was concave, these things diverge. When demand was convex, they converged. Or too convex, they converged, right? OK. So how does that lead us to think, Connor, that we can interpret the elasticity of marginal surplus? What property of demand can we identify that with?
It's just measuring the extent to which the monopolist's benefit changes as a function of the price.
Well, but what property of the demand curve were we just talking about that was associated with?
What do you mean? The convexity?
Exactly. Exactly. Yeah. So the more the 1 over the elasticity of marginal surplus is going to be greater than 1 for a concave demand curve. It's going to be 1 for a linear demand curve. And it's going to be 0 for a negative exponential demand curve. For a log convex demand curve, that's a very convex demand curve, it's going to be negative, right? And if it's negative enough, we get this increasing marginal surplus curve, which causes this jump and infinite pass-through rate, right? OK, Jing, how could we intuitively think about what might make a demand curve be more convex or less convex? That's true. So that's all true. The way I like to think about it is it has to do with the tails of the distribution. So you can think that for an inelastic demand curve, that's one where there's a lot of variance in how much people are willing to pay, right? Because that means that in order to change the quantity, you have to change the price by a lot, right? The more spread out people's values are, the more inelastic the demand curve will be. Whereas this measures something that's more like kurtosis. Do you know what kurtosis is? It's like how much it's like peaked in the middle and big at the tails relative to how much it's sort of like spread out in the middle part of the distribution, right?
Is these where your eyes are shaped like cones?
No, I don't think so. I don't think so. So in particular, remember we talked about power laws before. It turns out that under any Pareto distribution, anytime you have really fat tails, this thing is going to be very negative. When you have thin tails, it's going to be positive. So like for that uniform distribution, that corresponds to a linear demand curve, right? And that had very thin tails, and therefore we have this being positive. Negative exponential, less has bigger tails. And then as you get to really fat tails, like that Pareto distribution, then you're going to have negative 1 over the elasticity of marginal surplus. And in fact, the elasticity of marginal surplus is exactly alpha. So if 1 over alpha is exactly negative alpha, sorry. So as alpha gets small, as we get to a very fat tail distribution, we're going to get a large negative number for 1 over the elasticity of marginal surplus. So if you think that a good is a normal good, then things are going to have higher pass-through, more negative marginal surplus among the rich, because they have a more, because among the richest people, there's much more inequality in the tails. Similarly, products that sort of have a niche appeal, that appeal to a very elite group of people, are going to have very convex demand, very high pass-through. Things that are more utilitarian, that sort of everyone values a similar amount, are going to be more clustered together, more concave, and therefore lower pass-through. Another way of saying that is that a good that's a superior good, where people who have high income value it even more, that's going to get more spread out in the tails, right? And so that's going to be more convex, higher pass-through. Something that's an inferior good is going to be lower, is going to be more concave, have a lower pass-through. Okay, so just to give you one last visual representation of this, let's compare first these two cases. So this is the same demand curve, but I'm changing the marginal cost. Now, in a competitive market, right, as the marginal cost becomes flatter, there's going to be more pass-through, right? Or if it became negative, then there would be huge pass-through, right? And that's what we see here. If we increase the marginal cost, we move up the marginal revenue curve. That causes, when marginal cost is increasing, a relatively small increase in price. When marginal cost is decreasing, it causes a larger increase in price. But now we also have to worry about the curvature of demand. So if we compare a concave demand curve, an increase in marginal cost leads to a smaller increase in price, whereas with a convex demand curve, a small increase in marginal cost leads to a big increase in price. And that's also associated with a large consumer surplus in this case, and a large dead weight loss. It turns out you can relate this to dead weight loss as well, because remember that the pass-through rate also affects the extent of the dead weight loss, right, compared to profits. Well, in the concave demand case, we get a small dead weight loss compared to profits. OK? That's it for today. Thanks, guys. Make sure all your problem sets, if you didn't turn them in at the beginning,